Okay, so we're following on from the inverse functions into inverse trig functions. So we're going to break it up into 3 videos. We're going to have inverse sine, inverse cos, and then inverse tan. So let's start off with the first one, which is inverse sine. So again, you should be familiar with the sketch of sine x. It's a periodic function. It just keeps repeating. It goes negative angles. It goes positive angles. It just keeps on going. Okay, so x is your angles, and these are sine of the angles. Okay, so the ratios. So the greatest number is 1, greatest minus 1, and you oscillate between -1 and 1. So the inverse is, as we did before, switch the letters over, and then the opposite operation of sine is sine minus 1. And you've seen that on your calculator when you're trying to find angles to match ratios. And again, as I said in the previous video, sine minus 1 is not 1 over sine. Okay, sine minus 1 is an inverse function. So don't get them mixed up. Don't get them mixed up with indices. Okay, so x minus 1 is 1 on x. That's true. But with inverse relationship, it's not true. Anyway, so what is the inverse trig functions measuring? Well, it's calculating the angles for a given value. Okay, so for instance, if sine theta equals 1/2, then theta equals sine minus 1/2. And so your calculator is calculating an angle for a given ratio. So that's what inverse trig is. And you've been doing that since you were in year 9, but we just didn't call them inverse functions. Okay, copy that and come across. Okay, so what we've got to now look at is this horizontal line test. So if I do a horizontal line, it just keeps it keeps cutting in different spots, and that means we can't have an inverse because we've got multiple cuts. So what we need to do is we need to restrict the values of x so that we get the full range of the possible y values. So if I want to get all the possible y values, where do I go? Okay, and obviously we can't go forward because we have a cut straight away. So let's have a look at the next slide. So what we do is we actually just restrict it to some positive angles and some negative angles, and that gives us our full range from -1 to +1. So we can't go forward because we'll have 2 cuts at that certain value. So what we've got is the domain is restricted, and obviously the range never changes anyway. The range is -1 to 1. Okay, get rid of that. And for the inverse function, y sine minus 1 x, and I hope this is not annoying us. So the y range becomes the domain, and the range, so the domain, and that becomes the range. And what does it look like? It looks like this function here. Okay, so it's starting off at -1, starts off down here, ends here, and it can't have the same slope because it's a mirror image in the line y equals x, so it has to have the opposite concavity to sine, so that's why it's going in this direction here. You can't have the same shape because you don't have a mirror image. Okay, so copy that and come across when you're ready. Okay, so now we're looking at, for any given value of y, obviously there's an infinite number of solutions. So for instance, back in trigonometry days, for sine theta equals 1/2, we normally did all stations to central for 1 lap, but obviously we can have multiple laps forward, we can have multiple laps backwards, and to save time there's basically a formula to give us answers past the first quadrant. So the first quadrant is a straightforward one, and then after that we can use this formula for changing the value of n to work out other values. And so, like for instance, there's the first value for 1/2, which is pi on 6. Okay, and then for the other values you put n equals 1, n equals 2, n equals 3, and you can generate the other values that I had up here. Okay, so after the first quadrant you then use the formula to generate. So in your textbook there would be a proof on that, but basically if we just cut to the chase we can just copy that in. Okay, so copy those examples, and I think that's it. Okay, I'll just check. Nope, that's it. So that's the end of this video, nice and quick. Okay, and there'll be some exercises to do in your textbook or on Moodle. Bye.